All right, so here today we have a variety of stainless in different thicknesses. We have some 16 gauge, some 14 gauge, quarter inch, and the quarter inch has a PVC cover on it that the customer wants to maintain. Looks like this. It's not perfect. That's from how it was packaged when it came here, so you will see something on those spots. The parts pretty much all are always one solid blank and one cut blank. You see that basically here on our piles. We pre-tested something. We pre-tested a piece of 14 gauge simply to demonstrate how we can make a grain. Disregard this was something else here. There's a few scratches in here. But you see how nice and straight and even the grain is? And then we ran it perpendicular through the cross belts in order to refine this grain. So you have very smooth surface here, but you still have the full grain in the part. And then the 3/8 actually are the only parts that have enough grain where I would say you really need to use a white belt to remove this dross and then to round your edges. And we tested that here on this round part, and I want you to basically see, you see the white line around the outside that makes the radius. But this also, the way this was cut, it has an inside burr. And as you remove that you cannot touch that inside burr. I would urge you to change your cutting parameters where you see how far up the focus is. I would set that focus a little bit further down into the material in order not to have this side edge coming out here. This would take a lot to remove with a cross belt set very deep. It would cost you a lot of material. I think you could do a different laser setting, even if that means that you have a little bit more dross vertically coming out. It would still make a better part because you wouldn't have these things basically. And it's not that we are pushing this over. This is really from your cut. The way your cut is, you can feel that already before you put the part in. And that serration gives you the sensation of sharpness, even though it isn't. All right, so here we go. I'm going to start right away, and we're going to run all these parts out for you. But in terms of the demo, we're just going to run a few parts here so that this video doesn't go on for an hour. Not that it would take that long, but you will see how quick we can change over from 3/8 to quarter inch to 14 gauge, and then we'll do the 16 gauge last. All right, and in the beginning, especially with the thicker materials, we will just see how we can deburr this. And I will start with this part. So all we do is this needs to go fairly slowly because we need to remove that dross. And when you deburr something, you always want to run a little bit at an angle. That gives you the best deburr result. Okay? And now you can hear the grind. I lighten the head a little bit. This was done a little bit with a little bit more head pressure, grind it. And but therefore I increase the cross belt pressure. We are here, we have that thick material, we are about 3/16 below the surface. So here we're coming out. And you can see how clean that is, but you will feel the sharpness on the inside still because of the way you are cutting, right? On the outside we are getting a little bit more action from the block. It's not as prevalent on the outside as it is on the inside. But you see it comes out clean in one shot. and you see a little bit your white line here, which is your array. When we run the solid part, we can do the same thing. I'm actually going to slow that down a little bit more, going through the crosswell, just to demonstrate to you how the entropic improves if you go really slow in the crosswell. Okay? So we ran at the speed that we ran before, and now I'm going to tweak it down and make it slow as it enters that place. So that's not necessarily a practical way how to look at this application, because in your application you can only run at one speed. But again, if you had multiple parts and you can load the table, actually even that lower speed would be incredibly productive. A part of that size you probably would run 700-800 parts even at the slowest setting for the machine. And now you see a little bit of a larger white line. That's about 3 feet a minute, where the other part was about 5 feet a minute. There you have a little bit more radius, but you still have that roughness on the side here. Yeah, but nothing protruding. All that is nice and round. So we're going to write that on there. So that was white belt, which is always a P120 here today, plus cross belt, minus 4.5, right? And that was 5 feet per minute. And this was about white belt, P120, cross belt, minus 4.5, about 3 feet per minute. Now, as we go, we're going to do the same thing. Let's grab this, because this is really the worst part. You see you have a lot of things here on the surface, and this is why for this part you still need the white belt. The other 1/4 inch that you had was actually pretty good. This was a part 3/8 that you pre-finished. So, now I'll show you how we go from 3/8 to 1/4 inch. Finish. That's all you do. You change your material thickness. Now, as we run this again at about 5 feet per minute. Because I don't think that the 1/4 inch has that sideburr issue. Okay. I'm going to run this also right away with it, store it, and I'm going to run this straight. I'll explain to you in a minute why. See how much quicker this comes out. And you see the part is perfectly clean, and actually those edges you're really gonna like. This is by far good enough. That's all you need. So the 5 feet there works really well. We're gonna get to this side in a minute. So here, same result, very nice edges, everything good. But if you carefully look, you have the wave from the belt in the part because you're going very, very slow. Okay? I turn my crossbow off for a moment, and I have that at 2071, but I will take that out of the way. Okay? And now I will increase have a perfect straight grain. You see that? But we have a little bit sharp edges again because we ran with a white belt sander over. So now what we're going to do, now we are going to turn our white belt off, and we really need to wait until it is all the way out of the way. And I'm going to trick it a little bit. I'm also going to go a little bit lower, and I'm just going to compensate for that here. So now I'm going to turn on my cross belt again. And you don't have to go full speed, but you can go still pretty fast here, because all we want to do now is we want to refine this grain. And you notice how I went sideways so that we are parallel to the cross belt. And now you have a well-rounded, safe edge and a beautiful circle. I have a little bit here. That is still, I guess I didn't wait perfectly until my white belt was completely done. So I apologize for that. I hope that wasn't in the part before. Yeah. So this was, again, white belt P120, cross belt minus 4.5, and it was at about 5 to 6 feet per minute. And this one, of course, had that before too, but then in the end it was wide belt at about, I would say, probably was about 25 feet per minute. And then cross belt, so wide belt this way, and then cross belt that way at about 12 feet per minute. And that gives you a grain, a straight grain, where here you see the wave of the belt in the material. Let's cut that for a moment, John. We are moving on to the 14 gauge. Because I have my belt sitting fairly low, so now we're going to move on to the 14 gauge. I don't know that I can do this side. You need to pull all these things off, because you can't run this through a white belt sander. You could run it through a cross belt sander, of course, but that will totally contaminate your belt on a white belt sander. So you want to make sure that you don't have any goop on your parts too much that could load up your belt. And of course it makes a small difference for the thickness, but that's probably not that important. So here now, the way we were running, as I move that to 14 gauge, so I need to come up to the table. I can hear now, I'm starting to touch the conveyor belt to the cross belt, but not that much yet. So I'm going to go a little bit more. And again, for deburring, what I want to do first, I'm not going to run my white belt. I'm only going to run my cross belt. But I'm going to run actually quite a bit lower, because for the cross belt it is really important that you give it time, also in thinner material, so that it can work on that edge. Obviously, the material doesn't protrude so much above the conveyor belt, so the brushes have a little bit tougher time to reach that edge. So you see I ran diagonally again, and I have very little temperature in that part. I could use a little bit more pressure, but you can already see how soft that edge is and what that surface looks like. So this is cross belt only, and I will run the other side just the same. That was a burr side, that's the non-burr side, but we're going to give it a little bit more pressure. And because the combination machine to save time for the sake of the video here, I'm going to go fast a little bit. As we get to the cross belt stage, we're going to go slow again. So on a combination machine, you can turn any of the elements off and only run one and then the other, which we demonstrated to you when we ran this part. And I need you to look at that one more time, how nice that is. So here we see a little bit more debris. I have a little bit more temperature in the part now, and you will notice that this edge is rounder. It is rounder for two reasons. First of all, it was a non-burr side, and then secondly, like I say, we ran it with about 20,000, 30,000 more pressure. Now we are a little bit more in the conveyor belt. So this is like cross belt only minus 3.3 probably. Yeah, and that was, and this is cross belt only minus 2. So now, this was a part that we ran in 14 gauge like this one. I'm going to rerun that because we have some cross scratches in there. I'll do that for you in a minute. But right now what I want to do is I want to take this part where you see these deficiencies. And for that, you may need a wide belt. You're just going to run it through the cross belt. And see if that removes. I think that especially some of the weld splash, the back splash from the laser splash will be on the surface. Here you go. You see you have a very nice edge. That is all good. You see it didn't even remove fully my marker where I've noted down the material thickness. And on here, you will notice that you still have some of that splash. Here and here. Just a few spots here. Yeah. You feel it more if you run your finger over it. If you ran this with a white belt sander, this would go away, of course. And we have plenty of other materials where we can then demonstrate that for you. So again, this was cross belt only, minus 2.5 millimeter, no 3.5, a little bit heavier. And we are running at about 4 feet a minute or 3 feet a minute. So that goes here. Now the next thing that I want to do for you is I want to run some of your pre-coated material. In a pre-coated material, non-burr side, you run cross belt only. So again, we're going to change the material thickness. That's what it is. I think we have enough on this. And because it's a non-burr side, we're going to go a little bit quicker, just a tad quicker. And we're going to run this at an angle through here. And now, like I say, we do not have the white belt turned on. White belt is turned off. We only have the cross belt on, full speed, and that wasn't full speed by the way. And then about 5 feet, 4 or 5 feet a minute on the conveyor belt. And you see how it dulls. See, we have a very nice edge here. I think you will enjoy that. And your PVC coating is still fully intact. On a corner like this, where you are a little bit more exposed, you may remove a little bit more. If you want to do less, you either have to go lighter, or you would increase the feed rate, or you would decrease the cross belt speed. So, since we are here, let's deburr this right away. This does have a little bit of splash and things like that on it. So I am going to turn on my white belt, very simple. And we are going to run this like this. But at the same time, we're going to go a little bit faster. And again, not fast enough to make a straight line grain. That's not the purpose here. Because we're going to have a cross cast in any way, because we also have a cross belt. Here you have that one. Very nice. I think you will enjoy that very much. Smooth edges. Very well. So, and now the last thing we are going to do is we're going to do the 60 gauge here. The 60 gauge again, in order to, we have a little bit of weld splash on here. So we're going to do a quick round of deburr and edge guard. For this, we're going to bring this up a little bit, and we're going to go to 1.5 millimeters. Now I'm touching, I can hear it, I'm touching the belt, I'm just doing it by listening, and I'm going to go in another 20,000, which is going to be too bad. I'm going to go slower. Because this is the burr side, and again, we need to give the cross belt a little bit of time in this very thin material to reach it, and you can hear the white belt right now. Very nice part. I think you will enjoy that very much. We have a little bit of temperature in it. And again, we went to a 120 grit in order not to disturb the surface too much. We could have done a 60 grit or an 80 grit if you have really a lot of dross in order to be more aggressive on the dross to be faster. Now on the other side, I'm going to show you one more time how we grain it. We are going to turn the cross belts off, and we are going to take them out of the way. We're going to speed our conveyor belt up, and we are going to make a straight line grain in the arrow direction. See this? I have a little bit, this is a little bit light, probably the way the gauge was. My temperature, I don't have a lot of temperature in here, but I will do that same thing again, maybe in a different spot. When you do graining, you need to be really have a good abrasive, because otherwise you see every little thing in there from the deburring. So now you see, now you have a very consistent surface. Okay? Now, we will totally do the right thing, which means we are doing two things. We are turning everything off for a second. Right? And then in here, we can set the belt height, and we want to take the belt out of the way, which means we need to rotate this lever counterclockwise for the arrow to go up and to make it thicker. So we need a relief up here, and we're going to take this out of the way. Good. So now the belt is approximately 60 thousandths above the material and will not touch it, right? And now, with the cross belt, we're just going to run the cross belt. We're going to go a little bit slower, right? And we're going to go parallel to the grain, which means now we enter the part this way. Those are the abrasives that we have. The $1 million question is shifted a little bit, unfortunately. But still, you see it's a very nice grain, very smooth, and no cross scratches from the belt still being in there, right? And at the same time, good edges. The question that you had is, will that match? Will that match what we have? And you can see that the grain that you have underneath here is a much smoother finish, which means the 120 is a little bit too coarse, and this also is a much longer grain, which means a softer contact roll with a chip taken out. So if you wanted to do this, you would have to use like a 180 grain, and yeah, the contact roller is what it is. That you cannot change on the machine, right? So, but anyway, and I will mark that for you again. So that was wide belt at 25 feet per minute, going this way, and cross belt at about 15 feet per minute, going this way. And when I mean that way, the arrow means how we fed the part. Yeah. Yeah. And this is the demonstration. I'm going to run all the rest of these parts out for you, and then we're going to pack them up and ship them back to you. Thank you very much.